probably doesn't come as much of a surprise to you all that I, as a neuroscientist, study the brain. But you may be surprised to learn that, at least in a sense, I also study the gut, the stomach, the intestines. What we've known for a while now is that the gut and the brain communicate with each other. You all know this intuitively from experience. Your insides churn when you're nervous. Your stomach grumbles at the mere sight of a cookie when you're hungry. But this communication isn't limited to butterflies in the stomach. And it isn't a one-way street. Emerging research, for example, suggests that the bacteria in our guts may regulate how we respond to stress. Researcher Dr. John Cryan found that feeding mice a probiotic that changed a single bacterial species in their intestines prevented them from showing signs of depression or behavioral despair. What's more, these mice had lower levels of stress hormone in their blood. Basically, he was able to connect changes in gut physiology to alterations in the level of circulating hormones that make it up to the brain with changes in behavior. Now, a number of hormones that are actually produced by the gut can have effects on behavior as well, including feeding behavior and drug-seeking behavior. Glucagon-like peptide 1, or GLP-1 for short, is one of these hormones. We already know that if you inject GLP-1 directly into the brains of rodents, they eat less, and they're less motivated to work for food. Because of this, long-lasting synthetic GLP-1 analogs are now being explored as anti-obesity therapy. But this isn't the end of the story. We have hypothesized that GLP-1 actually plays a larger role in regulating how the brain interprets rewarding stimuli. If GLP-1 reduces the rewarding properties of food, one might predict that that the same principle applies to addictive drugs like cocaine. Somewhat astoundingly, we found that treating mice with GLP-1 analogs dramatically reduced the amount of cocaine that they would self-administer. Again, changing the levels of a hormone that are normally associated with the gut was able to change behavior in a dramatic way. Now, we have been interested in looking at the neurobiological substrates of this effect. So we've looked at brain regions that both express the GLP-1 receptor and have the neurotransmitter dopamine, that brain chemical that we associate with euphoria, with the high of drugs. Already, I have found that GLP-1 analogs prevent cocaine from increasing dopamine levels in certain brain reward centers. My PhD thesis work will further elucidate the mechanisms by which GLP-1 regulates dopamine homeostasis and drug-seeking behavior through targeted pharmacologic and genetic manipulations. This work is important because we have no drug therapies for cocaine addiction to date. Simply put, research to date has come up short. And when you're short on ideas, go with your gut.